Hi guys, happy Friday. So yesterday we started talking about visual data literacy. Today we're going to continue on that same path. I'm going to give you a short video here and then an assignment to do. So recap, make sure you turn in your TED Talk work. A lot of you guys did not. That's why we're doing visual data right now, is because a lot of people did not turn in their TED Talk. So this is plan B. And if you haven't turned in your pandemic project video, make sure you do that as well. Objectives today. Students will be able to evaluate visual data to determine what information can be gleaned from it and whether or not it is manipulative. So we have our standards there that this relates to in the Common Core. But why? Why are we doing this? Well, understanding how visual data can be used to both clarify and confuse information can help us to be more effective readers ourselves when we make these kinds of text, this visual data. And it can also help us be better consumers of information and when we're reading these things or seeing these things in the media, on social media, whatever it is that you're using. It can help us be more aware and therefore less likely to be manipulated. So we had this warm-up question yesterday, and you guys figured it out that it was kind of a trick question, right? We can't really tell who's doing better in English class by one score alone. It might be that we're more interested in their final score. It might be that we're more interested in their progress throughout the year or the quarter or the semester, whatever it is. But really, it's probably not fair to judge one of the numbers without considering the other. Numbers by themselves, they seem simple, but they often don't tell us the whole story. And then we also talked about how sample size and composition matters. We talked about, for example, my hypothetical survey of students and what color they prefer, and how that sample of 49 students might be a really good sample to generalize to all of my students, right, 80 ERWC students that I have. But it's not a good enough sample to generalize to the Coachella Valley or to the United States or to the world. And we talked about composition too. We applied that to gerrymandering and how when only certain types of people vote, then only certain types of people are represented. And that sample doesn't necessarily represent everybody. We also went into how visual data can be misleading. We looked at a couple different charts and graphs to kind of give examples of that. So this is one of them. We noted yesterday that the headline says the Times leaves the rest behind, but this first visual data here doesn't compare the Times to anybody else. It only shows us what the Times is doing. So that doesn't really support the assertion that's being made here in that headline. It also doesn't take into consideration the context of the rise of the internet and personal computers and whatnot, that it might be the context, what's happening in the world, that's causing this increase, rather than something that the Times is specifically doing. On this side over here, we noted that this bar graph does not start at 0. And whenever a bar graph does not start at 0, it's going to basically overinflate the differences at the top of that scale. So it makes the Times look like they're doing 2.5 times better than the Daily Telegraph, because this bar is 2.5 times the size of this one. But in reality, we realized that it was only about 10% difference. And then again, the Times leaves the rest behind, but it only compares against the Daily Telegraph. That's not really enough to support that assertion. So lots of flaws in the data, in the way that the data is presented here. The data itself is accurate. The numbers are accurate, but the way in which they are presented is a bit misleading when it's supposed to be proving this assertion. We also talked shortly about this graph here. We talked about how if you just look at this, if you just glance at it without really analyzing it, it's very easy to come to this conclusion that welfare spending has gotten out of control. It's increasing like crazy. It's, really down low here in 2009, and then in 2011, oh my gosh, it's like 4 times as much as it was in 2009. But again, we have the similar problem here where we're not starting at 0. Our baseline is not 0. And so the differences at the top are over-exaggerated. The real difference here is only about 9% from here to here. That does not look like 9%, right? We also need to look at the x-axis and how this covers really only about 2.5 years. and it lacks context. The 2008 recession caused a lot of people to lose their jobs, lose their houses, so it makes perfect sense that there would be an increase in welfare directly after that. And then we have our sample. We talked about how important samples are. This sample includes not just people who are on welfare, but also people who live with people who are on welfare. So they might not even be on welfare themselves, but they're still included in this chart. So the sample could possibly be skewing that data a bit. So let's try it a couple more times here. This is a really common chart that's used to kind of discredit the whole global warming thing. If you look at this, and the numbers are charted accurately, it looks like from 1880 all the way to 2010, there really hasn't been much of an increase in global temperatures. So global warming must be a hoax, right? So what's wrong with this graph? Take a second, pause the video, and see if you can think about what is wrong with this graph. So with the y-axis here, we have a lot of blank space above and below. That makes it look like there's been really no meaningful change. But if we're thinking about this, average global temperature in Fahrenheit, is the average global temperature ever going to be 5 degrees? Is it ever going to be 110 degrees? No, right? So having the blank space on the top and the bottom really kind of deflates the changes that occur in this, 65 to 45 degree area. It seems as if there's been really no meaningful change when you look at this graph as a whole. And there's also context. What we're missing here, 2 degrees doesn't matter on an average day. If Monday it's 96 degrees and Tuesday it's 98 degrees, there's really not much of a difference between those 2 days. But it does matter when you're taking this on a global scale, on yearly average temperature. Further, if you know anything about global warming, if you know enough about global warming and how it is studied, air temperature is a far less valuable measure for global warming than water temperature, measuring how cold or warm the ocean is. So even if it is true that the air temperature hasn't changed all that drastically, that's not the measure that's most important when discussing global warming. So if you don't know that context, then you might be misled by that graph. But here's an example of how it could be graphed if you zoom in a bit on it and don't have all that empty space above and below. Now you can see a more drastic increase than how it appears back here. This is also a really interesting one. So here's your question. How did the 2005 Stand Your Ground law impact gun deaths? Here's where the gun law was passed. What happened to gun deaths after that? If you said that gun deaths dropped, they decreased, you are wrong. Look at this axis over here. Actually, gun deaths increased after that law was passed. So in 2005, there were about 500. And then shortly after that, it was up above 800. What they've done here is that they've reversed the y-axis. Typically, we start with 0 at the bottom and go up, but they started with 0 at the top and went up, down. So it's kind of flipping our expectations. If you weren't paying attention, it's super easy to be misled by that. But this brings us to another question. Is it the 2005 Stand Your Ground law that caused the increase in gun deaths? This is an issue of correlation versus causation. So, one thing to know is that patterns in data don't always mean something. Here are some examples of where correlation does not equal causation. Just because something is correlated, something appears to match with something else, that does not mean that one thing caused the other. So here we have in black per capita consumption of margarine, so like butter substitute, and divorce rate in Maine. So can we say that consuming margarine causes people to be less likely to divorce, the more likely you are to have divorce, the less likely you are to have margarine in your refrigerator. No, right? That doesn't make any sense. They're not actually, there's no actual causal relationship between those two things, but they just happen by chance to map up pretty perfectly together. Here's another one. U.S. crude oil imports from Norway and drivers killed in collisions with railway trains. Again, how is our import of oil from Norway related to people being killed by trains? They're not. It's just pure chance, pure coincidence that these things map up together. Another one here with Internet Explorer and murder rate, right? Does using Internet Explorer make you more likely to kill somebody? Maybe while you're using it in the moment with the frustration, but probably not, really. Probably not. Here's an example where there is a causal relationship, but it's not between the two variables that are being studied. So we have an increase in violent crime and we have an increase in ice cream sales in certain months of the year. Think for a second of why that might be. If you said something to do with temperature and seasons and heat, you are correct. Ice cream sales go up when it gets hot. Very few people want an ice cream when it's negative 20 degrees outside. But when it's 80, 90, 100 degrees outside, an ice cream starts looking really good. The other thing that happens with heat is that people get more aggressive. They get more irritable, they're more likely to get into fights, so on and so forth. So yes, there is a relationship, but it's not that ice cream sales cause violent crime, or that after people commit violent crimes, they want to go get an ice cream. It's a different factor that correlates with both of those that causes that similarity. So again, patterns don't always mean anything. So here's another example of a graph that is misleading. Take a second, look at it, see if you can determine what's wrong with this graph. So if you said something about the y-axis here not starting at 0, that's not what we're looking for. With line graphs like this, you don't actually have to start at 0, and in fact, starting at 0 can be really misleading. So it's not that. In fact, what we have here is that the points are not plotted correctly. The numbers themselves are correct, but they are not plotted correctly. Look right here, 8.8. If I follow this line across, when I get to 8.6, 8.6 should be below 8.8, but it's actually above. So this number was not plotted correctly on this graph. Here's what it should look like. So again, a different message when you see this versus when you see this, right? 9 and 8.6 are not the same. Here's another example. What's wrong with this one? So if you're doing the math, what you should be doing is adding those numbers together. 63 plus 60 plus 70. It does not equal 100. Pie charts should really add up to 100%. It's not possible for 193% of people to back these three candidates. We only have 100% of people. So that doesn't really work, right? All right. It is your turn to analyze a graph. So this link is going to be on the Google Classroom. You're going to get this section up here above. You're going to be asked to choose a chart. Answer what is it trying to make us say, trying to make us believe, and then what is wrong with it. So when the person produced that graph or that chart, what did they want the audience to believe after they had seen it? And then, if you look at it with a critical eye, that's where you put it in number 2 here. What's wrong with it? What's misleading about it? What's not exactly accurate about it? Okay? So you have your options down below here. 3 options to choose from. And that's that. I'll see you guys on Monday. Some of you in person, most of you online. Have a wonderful weekend.